Hello guys, so I have 45 minutes or only 40 to get you excited about Room, a new library by Google. And now we'll just go straight to the chase because, like I said, I have lots of slides on only 40 minutes. So let's start with answering the most important question, why Google invented or created a new library. Of course, I have no idea why they did that, but I will try to answer this question anyway. So, slide about me. I gave a presentation about Binder. It's like this glue, important part of Android that it's basically internal process communication for Android. And in my presentation, I mentioned Dan Hagborn. By the way, awesome surname for a hacker. And Dan Hagborn, that's the lady in the middle, and please note who's sitting next to her. But getting back to Dan Hagborn, so Dan Hagborn, she wrote this famous blog post in which she said that Android team and basically Android as a framework, that doesn't provide us developers with something more than just like a bare minimum. If you want to go with MVC, MVVM, it's up to us. It's not Google or Android in this case won't give us anything else, just the bare minimum. And that was very true for last year or last couple of years. And out of sudden, now Google seems to care and provides us with more libraries. But what was before Google provided us with Room and this whole architectural components set of libraries was that communities, so us, started to fill in a gap. And for instance, there was someone who was talking about RxJava, that it's an important bit, and RxJava is a way to do things on Android. Others decided to just implement a full-blown clean architecture for Android. Some others were focusing on testing and trying to explain and find out a way of testing Android application, maybe with Kotlin, maybe using RoboElectric. Some others were deliberating and trying to figure out if it should be MVC, MVVM, or MVVM. And there is my friend who decided to stop doing any engineering because it was, I guess, too hard without high-level libraries and run and start doing business stuff, or basically sending emails. So now it seems that Google, they noticed that we developers, we community, we are trying to fill in the gaps, and they started actually to providing us with some higher-level components so that we don't have to reinvent them ourselves. So we have, I think the answer for this question, why Room was created, is because nowadays Google, luckily for us, seems to care. And it's not about this library. Like I said, there's a whole set of libraries, these so-called architectural components. And why we should start using those libraries? I think the reason is that it's not only Keyboard Surfer or Wojtek Kaliczynski who are working for Google, but more and more people from the community are joining Google, like Jake Walter or Florina. So I believe that we should trust them, so that there is lots of talent in this company nowadays, and those people, like in case of Florina and I guess also with Wojtek back in the day, they were sitting among us, so they really understand our pains and they really understand what we need. So in short, they seem to care. So let's talk about Room, and for Room I need a sample application. I will show you all the examples on my project I did for a client. In my application I have a main screen, it's a list of elements. In this case, these are invoices. And when I tap on one element from the list on one invoice, I go to a detailed screen, and on this detailed screen there's some more information about particular invoice. Back to the listing, each invoice is basically, this is a list of invoices, right? And each invoice is basically a set of, let's say, properties. So I have a name of an invoice, I have a bill to address, so I believe that its name is called seller. On the invoice, the proper term for that, the due date, status of the invoice, if it was paid or not, and the value or price of the invoice, okay? So each invoice has some properties. Actually, I believe 40 of them. And then on the details page, again, I have the same invoice and those details plus another entity. It's advance payment, okay? So each invoice has one, or in this case, two advance payments. So that's my app, and that's my data model. Quick recap, invoice, lots of properties, and advance payment, a few properties. Important bit here to notice is that there is this connection. Invoice has an invoice ID, and advance payment also has invoice ID. So one invoice can have many or zero advance payments, okay? So that's my app and my data model. So how can I implement that using Room library? And also I will try to, when showing you how to do that, I also try to show how you can do that using requery. Requery, which is, I would say, the best ORM library for Android, but sadly, it's not that popular. So how to implement that using Room? First of all, we need dependencies, and then there are a bunch of them, and actually this is no-brainer, you just copy that over from documentation. The only hard part is that they are updating versions because this is in alpha stage, so current version is actually not 4, but 9-1. And sometimes they introduce some problems, or let's say breaking changes, so at this stage, it's a bit painful. But it's not like every update from alpha 8 to 9 leads to problems, okay? So we need a set of dependencies, and actually that's that. And then when we try to create this room model for our application, we need actually 3 magic pieces, so to speak. A database, a model, aka entity, and something called DAO, so data access object, an object that we're going to use to access data, our entities from database. So I will start with entity and show you how to create invoice and advance payment using Room library, okay? So for an entity, first of all, I create a class. This is going to be a concrete class, not an abstract class or an interface. So this class can be also used in my application if you don't use this full-blown clean architecture. So this invoice can be also not only for data part of your application, but also can be used in domain layer, okay? So I create a class. I put some fields in this class, obviously, to keep all those information about my invoice. So ID, invoice number, or name. Some more information. Like I said, the list is quite long. In my project, at least 40 properties. Important part, they cannot be private, so either you make them public or just create a set of getters and setters. And we are almost there. All we need to do is add some special annotation so that Room will know that actually this is an entity for it to keep in the database. So we just add entity annotation. And if you want, we can change the name of the table. And actually, that's almost that. We also should mark which field is a primary key. In my case, it's going to be just ID, the same ID I'm getting from the backend, so unique ID for this particular invoice in the whole system. I'm also going to use this as a primary key in my database. As you can also maybe notice, I added column info annotation. It's not required, but if I use it, then I can change the name of the field. In this case, actually, it doesn't make too much sense, but for the second field, in my database, now the column going to be called invoice underscore NO instead of invoice NO with capital letter, okay? So if you want to change the name, you can use column info. If you don't do that, then all the publicly available fields from your class are going to be converted into columns in your database. If you want to put something that you don't want to persist in the database, you just add ignore annotation. Or in a recent version of Room, you can add a transient keyword. So it would be like public, transient, long, don't keep in database, okay? So that's my invoice. Now let's create advanced payment data, another module in my application. So I just add the annotation at the top, go with primary key, just like in case of invoice, and add maybe more column infos. So that's my model. I'm going to use this model in my application to store data, and also use this model in my application in the so-called domain layer, okay? The important part, I think, to notice here is that at this level, there are no relations between objects, and like I said, one invoice can have many advanced payments. So how can I describe that for Room, that there is this relation? And sadly, you cannot do that. You cannot do that with at the entity level. So even though there is this invoice ID here, and I have invoice ID obviously in an invoice, there is no way to connect that. I think in Django and also with requery, you can do something like that. So add this one, in this way, one-to-many keyword and say that this invoice should have a list of advanced payments. And actually, that works for requery. And also similar thing, like I said, in Django, it doesn't work with Room. So I cannot do that. And at entity level, to say that there is any relation, all I can do is basically to add a foreign key. So I just add that as a parameter to entity. So in this case, I'm just adding entity foreign key for advanced payment. All it says that there's this invoice data that's going to be like parent for this entity. I should take ID from the invoice data class, and this ID should match my invoice underscore
column in this class, and all I can do at this level is to say, when you're gonna be deleting invoice, please also delete all the advanced payments. Actually, you can tweak this, what's gonna happen here, but at this level, at the entity level, all you can do is basically just add this foreign key and mark that once deleting invoice, also delete all the advanced payments that belong to that particular invoice. But we can do another quite cool trick with Room, and that's called embedding, I guess. So let's imagine that in my invoice I have lots of fields that are basically just a price, right? This is like a gross and net amount and currencies like Polish zloty, for instance, and VAT rate and VAT amount. All this, basically all those 5 columns, and just one thing, right? Like price data, let's say. So I can create a POJO. Please note there is no add entity at the top. Then move all those fields to that separate class. Like I said, no entity at the top, and then use add embedded keyword to put that into my invoice data. It's not a full-blown relation, but later in my Java or Kotlin code, it looks nicer. So I just get invoice data and then I have price data. Even though all this information is one table, just like an extra column. So invoice data, in this case, invoices table is going to have all those extra columns. So amount gross, amount net, VAT rate, etc. Okay? So it looks nicer, but it's not a relation in a SQL world, let's say. Okay? Another cool thing I can do with entities, actually, I can store something else. Oh yeah, by the way, I should mention that you can do the same thing with requery. And it's important to say that requery was created before Room. So I would say that Google was strongly influenced by requery. Another cool thing you can do with your data at the entity level is try to store different kinds of types in your database than actually SQLite supports. So SQLite supports just longs and strings and not sure if something else. But in your application, like in this case, in my case, sorry, I have invoice status, right? Which I can store as a string database, but this invoice status, in my case, it's just like an enum with some more extra information. So it would be cool to keep this in database not as a string, but as a invoice status, right, as an enum. Actually, I can do that quite easily, both with requery and Room. All I have to do is just, in my POJO, put this type, like in this case, invoice status, and then create extra 2 methods, actually. So I use this type converter annotation. I create a class somewhere. I create two methods there. This one that's called from database. That's going to take the value. It's going to be stored in database. So let's say long value, and convert that into invoice status. So enum. And the other method also annotated with type converter. That's going to do the opposite. Okay. So thanks to that, and as you can see, this code is quite simple. Thanks to that, my POJO can have like other POJOs inside with add embedded keyword. I can store more complicated types at the POJO level, so like enums, for instance, or date type. And at the end, of course, in database, it's going to be kept like strings or long values. Also, I can play with foreign key here, but that's all I can do at the entity level. What's important to say is that with requery, you can do much more. Also, with requery, you don't have to create type converters for obvious types like date or enums, because requery provides that out of the box, okay? So that's quick recap. How can I model my data and then annotate it so that a Room can keep this in SQL database? The next step is how to create this database object. Basically, database object is a wrapper around SQLite opener helper. There's this class somewhere in Android, like low-level class that helps us to access database, to open database, begin transaction, and do upgrades. So that's database object in the Room world. And to create it, I just create an interface, so an abstract class. I extend Room database, and I add a bunch of code. First of all, annotation, that's important bit. This annotation takes the whole list of all my entities I use in my application. So in my case, it's invoice data and advanced payment data. Actually, this is not needed with requery, because requery is going to find all the entities in your code and automatically register them. Okay, so but with Room, you have to list them here. I can say what version of database I have. So like in this context, like what schema of database I have, like what tables and what columns in those tables. And also I can do this, which you shouldn't do this. By default, is true, and you should keep this as true. I will talk about this later. Just to show you that don't add, I added at first and I had problem with the testing and other things. And if I have type converters, I can register them here. So this type converter was this utility to convert from, let's say, enum to long, so I can store this enum in database. If I register type converter at this level, then it's available on all entities. I can also register this type converter at entity level, so then it's going to be unavailable for particular entity. So with that, then all I have to do inside my database is to list all so-called DAOs, and I'm going to talk about DAOs later. Basically, the rule is to create one DAO for each data type. I have invoice and advance payment, so I have 2 DAOs in my database object. I do that, and require is going to create a concrete class that's I'm gonna use in my application, but all I have to do is just provide this. So information about what entities do I have, what version of schema I use, and list all the type converters. That's that. And actually, in case of require, you do the same thing, but it's not abstract class, the concrete class, but very, very similar way of creating database with require. So I just said that. To be honest, I prefer the room version for creating database, but that's because it's less code that we have to write, and no much difference here. So now, how to make a query, and quick info what actually this DAO is doing in REM world. Okay, so I have my database, and I keep lots of data in my database. So entities, maybe it's not a perfect icon for an invoice, but that's my invoices in database. Okay. And then there's my application, and I need someone in between to get the data from database, from SQL database, from rows, from cursor, and then convert that into POJOs and give me that in my application. So that's why it's DAO 4, and it's like in the middle there. My application is making calls in Java, and those calls are being translated into SQL. Then this is everything done by Room and all the code that is generated by Room. Okay, and then Room is reading data from SQL. This data being converted, mapped to an object. The object I just marked with @entity annotation, and then I get this POJO in my application. So all this like complicated stuff, or let's say boilerplate code that is needed to read data from database, begin transaction, then use content values to get the data from cursor, and vice versa. It's all done by Room, and actually it's almost the same way with require. So how do I define a DAO? I start with interface, of course, annotate with @DAO annotation, and then all I have to do is start typing things I would really actually do myself. So if I want to read data from database, I need, I guess, method called getInvoice that's going to take an argument like ID of this invoice and return me invoice data. And actually, this thing will work. So I just create interface, this method, and Room will know how to create the whole code to read data from SQL and return this just like invoice data, do the mapping and the rest. If I'm using RxJava, oh, sorry, I forgot about one important thing, and I need to write the SQL statement. I'm always forgetting about this because it's scary, and also it's like also quite obvious thing. So I need to somehow explain how to get the data, right? So I have to write down this statement. This is not true for require, because require is going to generate all the SQL statement for us, and you have to do this in case of Room, which is actually quite powerful. On the other hand, you need to know what select from is, but it's not that hard. So yeah, to create a DAO, I create an interface, then I just create a method that I would just have in my application, and then I need to add a query so that this query can be executed when I execute this method. The rest, like mapping, beginning transaction, it's all done by, or reading data from cursor, it's all done by Room. So what if I use RxJava? And just forgot about this one. This is how you do this with require. This is, I would say, nicer API. Instead of writing select asterisk from blah, 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 all I do is just like call method called select, and then there's method called where, and there's method get that actually going to execute the statement, okay? So that's the required way of doing things, which is, I would say, nicer. But honestly, I prefer writing statements myself, SQL statements, because there's like more power there. And actually, you also can write raw SQL statements in case of require. So yeah, getting back to creating a DAO. So I can create DAO like this, and this is going to be, of course, blocking call. But if I use, I want to get a list of elements, I would just ask for a list of elements. As you can see, there is no ID in the SQL statement. But if we use RxJava, I can just use single here, and Room is supporting RxJava too. So I can use single, and in this case, of course, it's going to get me an object on an error if there is no object in database. In this case, invoice. I can go with flowable, and I can go with both, and there is a tiny difference between them, which at first was quite hard to grasp for me because there was no support for single, I believe. So with single, I can get data on an error if there is no data database. With flowable, I just make a query and then observe database. If there is a change in database, I will get an update from this particular query. So there is this difference. The hard part is that if there is no data in database, like there is no invoice with particular ID, the second one, so the method that is returning flowable, won't return me anything, and also won't complete because it's constantly looking at the database for new data. So that's quite tricky. So if you want to get data from database, even though there's only one invoice there or gonna be one invoice there, so you're gonna go with, and look for updates for that particular reason. You have to go with flowable, but you have to actually take a list, even though you ask for only for one invoice. So I go with flowable list invoice data. As you can see here in the query, I provide ID, so it's going to be only one invoice matching. That's primary key in my database, but still here is a list. Why is that? Because, yeah, flowable is observing data, and if I ask only for one, so without list like this, if I ask only for one invoice, it's not going to return anything, it's not going to complete, and it's going to wait for new data to arrive. But if I go with list, I'm going to get empty list at first because there is no data in database. And then, of course, flowable is going to wait for new data to arrive. And then if new invoice in database, the new invoice that's matching this ID, I'm going to get a list with this one invoice, OK? So that's a tricky part, and you have to be used to that. And I guess that's that. You can also get a list that's going to be giving you all the invoices in database, so I guess that also adds up to the confusion. Here is list and here is list, but this is going to be like true list of all invoices. That's going to be just like empty list or a list of one invoice. A bit tricky, but actually you can get used to that. If it comes to updates, all updates are synchronous, so you have to wrap them yourself with like completable from callable or something like that. So update invoice to update invoice. In my case, I just create a method returning nothing. I believe I can return a cursor or integer is going to be ID, but I don't remember that exactly. But there is a second version of update that returns something, I believe so. Anyway, asynchronous method, you annotate with update, provide it with one invoice or list of invoices, and they're going to be updated or inserted into database. Also, we can create so-called upsert with this on-conflict strategy. So in this case, if there is a record in database, it's going to be replaced. If it's not, it's going to be inserted. So that's that. And now back to relations, because there are no relations in Room at the entity level, but we can have relation at the query level. And it's by design. And if you want to have those relations, we have to add them, create them here at the DAO level, so to speak. Okay, so how to have this relation that I have one invoice and many advanced payment belonging to an invoice. First of all, we can do this. Never did that myself, but if you know what inner join is, you can write crazy queries like that. It's actually from documentation, and like I said, I never did that myself, so I'm not sure if it's even needed, but if someone wants, it's possible. The thing I'm using in my application, it's something like that. So this is a listing, and this is on the listing I have one invoice, but it's only the invoice overview, right? Let's say 3 or 4 properties, and in my database I have 40 columns. So it doesn't make too much sense to read all information from database just to show on the screen a couple of them, right? So what we can do here at the DAO level, actually that's not going to be relation yet, but that's a cool trick you can do at the DAO level. Instead of, in this case, select all invoices from database, but instead of getting a list of invoice data, I can get a list of invoice overview data. So create another POJO, and this POJO is going to have only those fields I really want to have. Also, there is no add entity annotation on the top because I don't want to create a separate table. And thanks to that, when I run this code, I'm going to get an error. Why is that? error looks scary at first. Actually, those errors are really cool. There are lots of errors. If you do wrong things with room, it's going to warn you that something is missing. You should do something in a different way. They look not that good because of the way it's shown in Android Studio, but if you add some line breaks, this error basically just said that I'm selecting all data, and then I'm reading that into smaller pojo. So there is no, that doesn't make sense to read all information from database. I only want to have like 4 or 5 columns from this table, right? So actually, the list of columns is literally copied from this error message. It was here at the bottom, right? So I just copied that list from this error message. And now I have a nice query that's not getting all the data. It's not a relation yet, but it's a funny thing we can do with DAOs and queries in Room. And now onto a real relation, which is done in, I would say, nice way. So this is my detail screen in my application. On the top, I have information about invoice. Let's say that's all the fields I need from database, all the columns from database I need for this information to be shown. At the bottom, I have lists of all advanced payments belonging to this invoice. With requery, and as maybe remember, all I have to do was create an invoice class and add this annotation that invoice class has a list of advanced payments, and requery would create all the necessary code for me to query database. What can I do with Room? Actually, we can make a query at the DAO level. As you can notice, that there is another different pojo in here, right? This pojo is basically a class that has 2 things. One is obviously my invoice, because I need invoice for the top part of my detail screen. The bottom is a list of advanced payments that belong to that invoice. And what I do, of course, I need to add this statement here. So select all information about invoice, because I'm going to need all the information about invoice. And then I just add and actually reuse the add embed annotation here, right? So I say, okay, get all the information and basically put it inside invoice data object, okay? And then for the rest, so how to get all the advanced we can use another annotation called add relation and tell Room that there is this relation between those 2 classes. So parent column ID, so that's invoice ID, should match invoice underscore ID from advanced payment class. So in this way, I can make queries like there is a relation, but even though I don't write this relation as annotation at the entity level, okay? And this is super useful compared to, I mean, this is also useful, sorry for jumping. This is also useful, but the other way I would say it's easier to understand. The only strange thing about this add relation annotation is that it's not in the official documentation, so maybe they are not sure if it's gonna like be in the final version, or maybe they don't want to promote it yet. So hopefully they will keep this add relation thing because it's quite useful. And I use this query to get information for my detailed invoice screen. So just one call to DAO, and then I get this object with all the advanced payment read from database for this particular invoice. So quite useful. So quick recap. We have to write queries by hand. We can do that with requery, but we have to with Room. I believe they're gonna take this take this approach also and add some nicer API, maybe in Kotlin. And we can do all the crazy advanced queries with joins and whatnot because we write all those queries by hand. And there is this nice add relation thing, which is, for me, is super useful. Okay, let's talk about testing. This is an important bit, and of course, everyone is testing. So how do we do tests with Room? Instrumentation test, that's the first thing. Second thing, we need this extra rule so that, because Room has its own scheduler, so we want to use instance scheduler so that don't provide for tests our own. We can, but we don't have to. So that's the rule. For a setup, of course, I need my database. So that's this object I'm creating with Room. That object that has all the entities and all the DAOs, right? Magic line of code to create Room. The important bit is basically this is the same thing I'm using in my core application code, but in this case I I use this in-memory database builder, so this database won't have a file on a device, it's going to be quicker. And of course, I close database in teardown, and then I can start writing tests. It's wise to have like also DAOs as a fields in your test for the test units, test methods, and then you just write your test code. So in this case, it's just like a random bullshit test code I wrote when I was learning how to make queries with Room and how to observe database for changes. But as you can see, when I have a DAO, I can insert project, and if it is a single, I can just call test method to get a test subscriber. Then I can just make sure that this test subscriber is not complete. There were no errors, no data yet at this level, or actually empty list. And then when I insert a new project into my database, I'm going to get a list with one task to my new project. I'm going to get a list with this one task, okay? So just if you write tests, you can easily use this in-memory database. Of course, you don't test database like this. You most probably test your repository, right, and at higher level. But you can just like use, you don't have to mock a Room. You can just inject it there and use this in-memory version, and it's going to just work just fine, okay? But what's cooler is migration and testing migrations. And this is thing I was never doing myself. I was doing migration, obviously, but never testing that. So quickly, how one can do that with Room. So first, let's start with migration. This is my invoice. Back again, some properties in this invoice, and let's imagine that I want to add a new field to my invoice, okay? And let's call it a new field. So I can do this in Java just fine, but obviously that's going to lead to a problem later, because when I started my application with the version 1 of Schema, basically there is this create table statement that's being run, and this create statement is what created my table, right? When I added a new field to my Pojo Java object, this field is not here in this table. Someone has to add this field, right? In the end, I need schema like this. So how do you do that with Room, or also the same thing with requery? You just create migration, but if you don't do that, you're going to get this error, which is quite obvious to understand. Sorry, there is a different schema in this new version. You need to add migration. To add migration, you can first of all start with bumping version number. So in my case, that's number 4. It can be also a date. So some people just prefer to use like date, so year, month, and day. Some just numbers going up. So there was number 4. I added a field to my invoice object. Now I'm bumping this number to 5. Will it work? Of course not, because even though I added this object to field to my object, I bumped number. Still, there's no one to convert one table to another. So that's the migration, and it's for this particular reason. How to write migration? Super simply, it's just a class. I create instance of the class. I have a method migrate. In that method, I just write some SQL statement. And this is basically how you do migrations. Also, if you use low-level SQL API, if you use requery. The cool thing here, this migration is between version 4 and 5. You can do migration between version 1 and 5, so skip like migration steps from 1 to 2, from 2 to 3, from 3 to 4, and so on. You can go straight from 1 to 5. And Room, as far as I know, is trying to find the shortest path. So if you have like 10 migrations going each version, and one going like from 1 to 5, and then second from 5 to 10, Room's going to go with those 2 migrations because less methods to be called, okay? But to do a migration is as easy as this. If something is harder, because this one is super easy, it's not because of Room or requery, it's because of SQLite. So if you want to change type of a column, you have to create a temporary table, I believe. So but that's not a Room fault, right? And migration has to be registered at the database level. So that's my way. That's why creating a database. How to register? I just add a method, and then I list all the migrations, okay? And how to test migrations? Best thing, I never did that. Before this presentation, I created my very first test for migration, and I'm really happy, and it's really super easy. Few steps. First of all, don't disable, like I did, schema exporter, because preprocessor will create lots of JSON files to be used later for testing migrations. Add some things to a Gradle file, boring things you can find in documentation. I believe you need to also add a dependency 1 or 2 for migration testing. And then, how do we create a test? Actually, it's super simple and funny too. So another instrumentation test. Of course, I need a name for my database file. I need this extra one rule, and that's going to provide me with migration test helper. This test helper takes context and my database, so this database that contains all my entities, version of a schema, type converters, and DAOs, and some other classes like framework, SQLite, Open Helper, Factory. So we need a name for database. We need a migration test helper and this rule. Next. Oh yeah, we need a method to create data, but like for the very first version of database. But sadly, we need to do that before we start Room. So we need to create a method that's going to create my very first invoice with schema number 1. In my case, actually, it's 4. And this method has to use low-level APIs, so content values. It doesn't look too cool, especially when we just were playing with Room and nice APIs. But for tests, we have to do that, okay? But it's not that hard, as you can see. Just content values, a few fields, and then just insert that. So we need this method, and then we can glue this all together. So how it looks. This is one a test method in my code that's going to check if data was converted correctly after changing schema, okay? So how do I do that? I use a migration helper and ask migration helper to create the first version of my database. In my case, it's not first, but fourth. But I ask migration helper to create database. Second, I insert data there using this low-level API, so there is no room involved at this level. So now I have a database with data inside. Then I ask migration helper to do the migration. To version 5, I provide with name of the file on the disk. True stand for don't delete something. You just put through there. I have no idea what's that. And then you just provide a list of all migrations you want to apply. And then what's going to happen, this database that was in version 4, having this one invoice, it's going to update it. So now it has this extra field called new field, by the way. And also some data was maybe changed. Now I have to check if the migration went OK. How do we do that? I just create room at this level, room database at this level, and then I can use this room database to get DAOs and make queries. So now I can make low-level queries like my application will do to get data, in this case, invoice from database using Room API, and then just do an assert. In my case, I added new field, and this line add column new field had line at the end default 0, but for this test I changed that to 4. So now I'm checking that this migration went well, so I have new database with this extra field, and also when I read data from this database, my invoice is there because I inserted invoice in the previous version, and after migration it's still there, and also has this extra field set to 4. So not only schema change went OK, but also data, if was there, it's still there and has this change applied. In this case, this new field with value 4. And as you can see at the end, the whole test for one migration, quite simply, but it's super easy. And I know that in Florina's code on GitHub, she has some utility methods that can make this even shorter. But in the end, it's as simply as this. So to sum this up, Room is really cool alternative if you, for whatever reason, were using low-level APIs. But it also can be attractive for query IO users like myself or GreenDAO users, because it's, like I would say, almost there if it comes to features. For sure, there are going to be more features from imported from requery, and you can mark my word that because right now they have like half of the features from requery, like literally the same annotation, the same idea, so I can expect more to be imported. And then, of course, the important bit I would say is the Florina factor, because maybe you heard about requery or maybe not. It's really awesome library, but without someone speaking about this library, there is no like wild knowledge and no users, no friends to ask for help, no posts on Stack Overflow. And with Florina and other developer advocates for Google, you have awesome presentation, awesome blog posts, and even more, okay? So I would say that's important asset for Room. Nicely done library, but others also nicely done. Lots of support from Google at the advocacy level, and that's a game changer. Just one important bit, because I was talking about requery, which I said is awesome. That's the author of requery library. So just hat off for this guy, because all those features you see in the room, I would say they were inspired by this guy. And the sad part about requery is actually not him, but this stat from GitHub. As you can see, he's only committed there 4 people together, some small comments, like 7 comments, most probably typos somewhere in README. So knocking wood, if something happens to this guy, or if he decides to start doing React Native and other things, there is actually no requery IO anymore. So that's that. If there are any questions, I'm happy to take them.